in order to finish up talking about pure hydrocarbons, alkanes, alkenes, alkynes, we need to merge the rules that we've looked at so far together, because we often have molecules that have multiple of these complexities shoved together. I've got right here 3 molecules that all have 2 of the things we've talked about. The first one has both a double bond and a methyl group, but this should be no problem because double bonds get a suffix. Methyl groups, prefix. So let's put these together. Let's start by numbering our carbon chain. I've got a 1, 2, 3, 4, and 5. Notice I always start my numbering with the constituent at the lowest carbon. This will come back up later. In order to name this, I've got a 5-carbon chain, pent. It has a double bond starting at carbon 1, so pent 1-ene. And I've got a methyl group on carbon number 3. So I have 3-methyl, pent 1-ene. Nice and straightforward, nice and simple. Let's write that a little larger. 3-methyl, pent 1-ene. Okay. Next one. I have both a double and a triple bond. Let's number those carbons, get our prefix out of the way. 1, 2, 3, 4, 5. So that is also going to be pent. Now I need to know, do I call this an ene or an yne? The triple bond takes a higher priority than the double bond. But we still need to identify that there is a double bond there. And so I kind of mix these two together and make a Frankenstein name. So pent, and it's going to be N-yne. It's going to look like that. But I still need to put the numbers in here. So I've got here pent 1, N, and then 4, yne. Now, this name is actually incorrect. Because the alkyne has a higher priority than the alkene, I actually need to number this starting from my constituent that has a higher priority. So I actually need to flip my numbers around here. This is going to be the case in all organic structures. So far I've been drawing them from left to right, so we've been numbering them from left to right. However, I need to number these according to the constituent. Because even if I did number this left to right, I could always pull this out of the board, flip it around, put it back, and it would just be reverse. So we always number with the highest priority constituent getting the lowest possible number. That means that this becomes pent 4N1-yne. Okay? Great. Next and last, I have multiple side chains. Let's number this molecule, and remember, our constituents are over on the right side. We're going to need to start our numbering from that right side. So I've got a 1, 2, 3, 4, 5, 6, 7, and 8. So this is 8. That means oct. I don't see any double or triple bonds, so it's going to be an alkane. So octane. On the 2-carbon, I've got a methyl group. On the 3-carbon, I've got an ethyl group. Now, how do I write these in? There is an official formula for writing these in. We're actually going to put them in alphabetical order. So even though my methyl group starts in the 2 and my ethyl starts in the 3, E comes before M. So I'm going to write 3-ethyl. And I'm going to run out of room here, so I'll rewrite this. I'm going to rewrite this up here. I'll have 3-ethyl. And then 2-methyl octane. There we go. 3-ethyl, 2-methyl octane. That's how I name multiple side chains. Hopefully you're starting to see how these names are really just puzzle pieces that are fitting together. Here I've got a trick question. How do I name this? Now, if I were to just go at it and number it like I've been numbering, I would say I've got a 1, 2, 3, 4, 5 carbon chain with a 1, 2, 3, 4 side chain. But our parent chain always needs to be the longest carbon chain involved. So I'm going to put, instead of going 3, 4, 5, instead of saying pentane with a butyl side chain, this is actually going to get numbered like this. This will get 1, 2, 3, 4, 5, 6, 7. That's why I've got a 7 carbon chain here with a 1, 2 side chain. So I need to name this according to my longest possible chain. So this becomes heptane. Heptane with a 1, 2 ethyl side group. And that starts on my 3rd carbon.